Okay, so what we're doing is we're taking b plus d, we set up a chart that said, here's our x components, here's our y components. Now, this is the most critical step that you do, is that you take these, some of these x components and the y components, just from the chart that we just filled out, and you draw a new triangle. So, here's my origin. My x component is going to be over negative 2.05, and you always deal with your x component first, and then you have your y component of negative 2.64. Okay? The beauty of this is that now we have a right triangle. Now, to find that resultant, now we can use the Pythagorean theorem. Okay? Now we can go, ooh, now I have a right triangle. Now I can do a squared plus b squared equals c squared. That I couldn't do before by drawing it out in the old-fashioned way where you go b plus d. Okay? It works, but that's not a right triangle. This method gets me a right triangle, and then I can use the Pythagorean theorem to end up by finding the resultant. Okay? See the difference between the two. So somebody do the Pythagorean theorem. Take 2.05 squared plus 2.64 squared and then the square root of all of that. What'd you get?
3.34.
Now, if you just tell me the resultant is 3.34 centimeters, is that enough information?
No.
No, because what's the only thing you've given me?
Magnitude.
You've only given me the magnitude. Cool, it's 3.34. I don't know what that means. Now, this is where your calculator lies to you, okay, or at least doesn't tell you the whole truth. I need to find, in effect, that angle, okay? This is where your calculator just doesn't tell you the whole truth. So I would use inverse tangent. I wouldn't use the hypotenuse, because if you screwed up the hypotenuse, then you're going to screw up the angle. Okay, I would just go off those x and y components. This is, and by the way, if you don't know these steps, look on the lecture, on the sheet of lecture notes that I gave you all yesterday. It's there. Okay. So what I would recommend is the inverse tangent of your opposite, which is 2.64 over 2.05. Now, technically, those are both negatives, but it's going to work out to be positive values anyway. So if you do this, what does your calculator say the answer is? What'd you get? 52.1? 52.7? Hold on. I've written two different. What do you get?
52.17.
So 52.2. Three significant digits. But here's the problem. If you tell me 52.2 degrees, where do I think that is? I think that's somewhere up there. Okay? So you're going to tell me that one person kicked the ball this way, another person kicked the ball that way, and the ball is going to go up like that, which makes no sense. This is why your calculator lies to you. Okay? You're going, man, Burkamp, my world just got ruined. My calculator didn't, oh man. Get over it. But what can we do with the 52.2? Oh, we could add 180 to it. Okay? So this is why it's so important that you draw this out. Because if you didn't draw this out, you would just put 52.2 degrees because that's what the oracle says the answer is. Okay? This is why you make that sketch. So, when you take 52.2 and add that to 180 degrees, then what do you get? 3.34 at 232 degrees. So that's what I want on that line. That's the resultant that I need. Now, let me show you how your calculator, again, will not do you a solid. let's just say that had been negative 2.05 and positive 2.64. So we need to deal with some different scenarios. If we had had negative 2.05 and a positive 2.64, would you still get the same resultant?
Yes.
In terms of magnitude,
Yes.
right? You still get the same value of 3.34. That wouldn't change. But again, this is where your calculator lies to you. So if you punch into your calculator the inverse tangent of 2.64 over negative 2.05, what does your calculator say the answer is? What'd you get? Negative 52.2 degrees, which doesn't make any sense, okay? Because if you tell me negative 52.2 degrees, like, I don't know where that is, okay? I got nothing. I don't know if it's like down here, I don't know if it's here, I don't know where negative 52.2 degrees is. This is why you always go off of that positive x-axis. Now, if it had been, and again, this is just me. If it were me, I wouldn't even mess with that negative sign. I would not even jack with it. I would just find 52.2 degrees. Then I would decide, oh, I need it from this angle, so what are you going to do? Subtract it from 180. Because now, out of curiosity, just do me a favor. Somebody just divide out. I just want the quotient. If you take 2.64 and divide that by 2.05. Let me show you the old school way to do this.
1.28.
What'd you get?
1.28.
1.28. So this is what I would do if I were all of you in my high school class. If you take the 2.64 and divide it by 2.5, what'd you get?
1.28.
1.28. So what I would do is I would go to this chart and I would go down the tangent column until I found something close to 1.28, which is closest I got, yeah, I got 1.28 exactly. So I've got 1.28. So I would find 1.28 in this column, and then I would go across and go, oh, that's 52 degrees. So that's what I would do. I would reverse the process. I would find the numeric value after I divided it, and then find the angle that matched up with that. It wasn't the most efficient process in the world, okay? But you did have a deeper understanding of mathematics because you had to spend much more time thinking about numbers and how they were related. Okay, so here's the deal. So I'm done. So you finished 11, 12, 13, 14. Now, here's going to be my promise to all of you. If you choose not to draw the charts, you all are big people. If you say, Brookhamp, charts are old school. I don't need to draw the charts. That's fine. But here's the deal. If I don't see the chart and your answer is wrong, you will get absolutely no partial credit. I am not going to waste 1 minute of my life, not even a second of my life, trying to search through random numbers that have no meaning. So if you feel good enough that you don't need to use the chart, roll the dice. That's fine. But if that answer is wrong, all the points are gone. I am not going to go through and find out anything that you might have done wrong to give you partial credit. So that's the roll of the dice that you have. So I'm done. This is due tomorrow. That's all the homework that you have.